would like to be as quick at multiplication problems as you are with like addition problems, which is awesome. You need to be. So while we are learning multiplication, I'm going to be teaching you a trick to be learning your math facts quicker. Okay? So close your math notebook. Just have it out, but keep it closed. Okay. I want you to use the equation, 2 times 6. What is 2 times 6 again? What's that product? Product of 2 times 6. Have a strategy. Just sit here and look at my pretty face. The answer will never be there. You can do repeated addition. You can skip count. You can double. 2 times 6 is what, Ryan? 12. So using this equation, I want you to solve. Oops, that's 16, sorry. 4 times 6. So I'm giving you 2 times 6. How can you use that to solve 4 times 6? Your notebook is closed. Thanks for following directions. Your body's on the other side of your desk. Could you skip count and count on by 4s? Sure. But if I'm giving you this equation, how can you use that to help you solve this? Lindley, what do you think?
You can double the first answer.
Lindley thinks I can double it. Are 4s doubles of 2s? Yes. So, Lindley, what is 12 doubled? 24. Hey, guess what? 4 times 6 is?
24.
Did Lindley have to skip count by 4s?
No.
Lindley, are you super good at skip counting by 4s?
Yeah.
Yeah, you are. Cool. I'm not. I try not to do that, and I'm definitely not good at skip counting by 6s.
No.
But if I know my 2 times 6, I can use that to figure out 4 times 6. All right, let's do another one. Using 2 times 11 is 22.
Yep. Yeah.
I know that. Because 2 times 10 is 20. And if I add one more group of 2, I've gotten to 22. What must be 4 times 11? It's going to be 4 times 11. I'm giving you 2 times 11. How can you use that to figure out 4 times 11? I do not want you counting on. I do not want you skip counting. I want you using the math I've already given you. Piper?
42.
It's not 42. Close. Sabrina?
30.
Nope. Maddie? 44. If I have 2 times 11, a 2 by 11 array, to make that a 4 by 11, I have to add another 2 by 11. So I'm doubling my product. 22 plus 22 is 44. We'll do a lot of this. It's okay. If you're still a little confused, that's okay. We're going to do a lot of it. Sabrina. It's doubled. Okay? So if I make a 2 by 11 array, right? To make this 4 by 11, I have to double this. I have to do that again. Right? If I know the answer to the first part, do I know the answer for the second part? Yes, they're the same thing. 2 by 11 and another 2 by 11. So if I know this, I can double it to figure out this. We'll work on it. Don't think that you have to know that exactly right now. We're going to do a lot of it. Okay? All right. Today, we're going to be working with 5. Yes, I like 5. We're going to be working a little bit with 10s too, but we're definitely going to be working with 5s. Get out your counters, please. I do not want you to make anything with them yet, but I want them out on your desk. So we've been making a lot of arrays with our counters and with drawings. We did arrays of 1s, we did arrays of 2s, we did arrays of 4s. And arrays are good, but you only have so many counters. Even when we were making some really big arrays, you guys were running out of counters. Conveniently, arrays are just patterns. So I'm going to show you how to do a fast array, which is just a shortcut to making an array, but you don't need as many counters. Yes, Emily? Yes. Okay? So if I was going to create an array for 5 times 9, that's a lot of counters.
Yeah.
Because I have 5 groups of 9. That's a lot. So instead, we're only going to do the first row and the first column. Because the rest, you can fill in with your brain. Okay? So with your counters, I want you to make 5 rows. 5 rows. And then we are going to do 1, Madeline, listen to what I'm saying. 1 line across of 9 columns, but I'm not going to fill in my array. So 1, 2, 3, 4, 5. So your array should look like a funny L. Like down L? Correct. That's it. That is it. Do you know what goes here? Do you know what goes there?
Yeah.
Yeah. That's a group of 5. Do you know what goes here?
Yeah.
Yeah, it's just a group of 5. So do I need to fill in the whole thing?
No.
Do I need to fill in the whole thing?
No.
No. So as we are making arrays of these really large numbers, don't waste your time filling in all those dots. Make a fast array. And you can fill in the rest with your brain. You know what goes there. Jackson, you're raising your hand. Do you have a question, or were you going to say something?
I was going to say something.
Go for it.
It's kind of like our hundreds chart. There's the columns go down and the rows go up.
Exactly. Exactly. Go ahead and draw your fast array and label the equation in your math notebook. So a fast array, again, does not draw all the dots. They only have that first row or first set of columns. So go ahead and draw your fast array in your notebook and label it with the equation that you did. So we were working on a 5 by 9, 5 times 9. All right, we're going to work with a hundreds chart. And we're going to use it to skip count by 5s. Okay, I'm going to get you, what is it called, hundreds chart in just a second, then we'll skip count. All right, ready to skip count by 5?
Yes.
Follow along in your hundreds chart. Ready? Go.
5.
No, no. There's no reason to go that fast. We did not go that fast with 2s. Get yourself under control, please. 5, 10, 15, 20, 25, 30, 35, 40, 45. We did this yesterday, but we did it with 2s. Today we're doing it with 5. So get a yellow crayon and color in the products of our 5s, please. Whoops, I colored in the wrong one. After you have filled in your products of 5s, looking at your hundreds chart, what are some patterns that you see? What are you starting to notice? I want you to write down at least 2 patterns that you see in your math notebook. Alright, talk to me. What are some patterns we noticed in our 5s, with our products of our 5s? What did we notice? What do we notice? Remember, if you don't have it in your notebook, when someone says, we need to add it to our notebook. Santiago, what did you notice?
And I noticed about the 5s
Yep.
that the numbers go by odd.
Is 0 an odd number?
No.
Oh, that's a good start. Not 100%, right? Lindley?
I noticed every 4, the 5th is colored in.
Okay. So it's 1, 2, 3, 4, 5. Okay. Good. Good. Ava, what do you notice?
That on the 100 chart it will like be an odd and then an even.
Oh, so the products. I'm writing, you're writing, unless you already have it. Of the 5s. Go odd, and then even. And then odd, and then even. And I'm putting dot, dot, dot to say that continues on. Odd, 5 is an odd number. 10 is an even number. 15 is an odd number. 20 is an even number. Odd, even. Interesting. Emily, what did you notice?
Going down, counting by 10s.
Oh, in the hundreds chart? Yep, but that's a product, that's a pattern of our hundreds chart, not a patterns of 5s. Naviana?
I noticed that 5s go down.
Okay. Gabriella, what did you notice?
I noticed that it's also counting by 10s, and if you go down the 5s column, they all end with 5.
Yep. That's a product, I mean, that's because it's in the hundreds chart, though, not necessarily because of our 5s. Aiden Washington, what did you notice?
That at the end of 1 is it goes 5, 0, 5, 0, 5, 0.
Yeah, our 5s, when we are looking at our products, they only end in either 5s
Or 0.
or zeros. If I multiply something by 5, can I get the answer 22? No. Ever? No. No. So fun fact, if you're multiplying by 5 and you get 22, you're wrong. Yikes. The products. I'm writing, you're writing. Thank you. They either end in a 5 or a 0. Interesting. Interesting. Alright, please place your hundreds chart on the page that you're writing your notes once you've gotten it down. Alright, I want you to get some counters out. And what you're going to do is you're going to do it on your desk first, and then you're going to draw it in your notebook too. So I want you to create a 5 by 2 real array, not a fast array, a full array, in yellow. And then next to that array, I want you to create a 5 by 2 array in red. You're making it on your desk first, and then you're drawing it in your notebook. So we had Go ahead and draw yours out. You had a 2 or 5 by 2, I guess I should say. Array. And then we squish that together with another 5 by 2 array. And if I colored all these dots the same color and made them one array, like I turned them all red or I turned them all yellow, what size array would I have? If I turned all my dots either all red or all yellow, made them all the same color, what size array would I have? Ava?
You would have 2 columns of 10.
2 columns of 10. A 10 by
2 rows of 10.
2. 2 rows of 10, yep. Are we good? Sabrina, you good? Do you understand what I'm doing?
Yeah.
Took a 5 by 2, another 5 by 2, and I swished it together, and I got a 10 by 2. Good. What's the product of my 5 by 2? Santiago? 10. What's the product of my other 5 by 2? Javier?
10.
Still 10. What's my product of 10 by 2? Sabrina?
20.
20. Weird. Weird. What does that remind you of? Make sure you have what I've written in black in your notebook. What does that remind you of that you have already done and seen before? Aiden Washington, what does that remind you of?
Addition.
It reminds you of addition? How so?
5, 10 plus 10 is 14.
Okay. Okay. Ava, what does that remind you of?
Also reminds me of adding, but like you're still having you still have an array, but you're also putting it just like addition, yeah, and multiplication into 2 groups, and then addition you'll just have like 10 and 10.
Interesting. Emily, what does this remind you of? Okay. Sabrina, what does this remind you of?
Addition.
Addition. Can I tell you what it reminds me of? Ryan, what do you think it reminds you of?
Addition.
Addition. Yeah. This looks like one part of my array, and this looks like another part of my array. And when I smush them together, I probably get the total array or the whole. Isn't that cool? Isn't that cool? That's what it reminds me of. And so by you guys saying addition, you kind of see that. You're adding your parts together to get your whole. Yes, ma'am, Sabrina.
I have something to say about it.
Go for it. This time we're going to skip count because we're working with 10. We're working with 10. Go ahead and put away your yellow crayon if you still have it out. Excuse me. And I want you to get out a blue crayon because we're going to color in the products of our 10s in blue on our hundreds chart. So we are going to be skip counting by 10s. Ready, set, go. 10,
20, 30, 40, 50, 60, 70, 80, 90, 100.
All right. Color in your hundreds chart the products of your 10. And you're using blue. This is basically what it should look like. It probably turned green. Remember we had that conversation, yellow and blue mixed green. What are some patterns or some things that you notice about the 10? What are some things that you noticed in the 10? Underneath, where we've done that array that we just did together, the part, whole array, draw a line. And underneath that line, I want you to say what I noticed about the 10. And then write to me, what do you notice? What are some things you notice with our products of 10? You know, a lot of you have very similar things as I was walking around reading over your shoulder. Colin, what's one thing you noticed?
Every number ends in 0.
Every product
Ends in 0.
ends in 0. So if I say 2 times 10 is 22, am I right?
No.
Could I ever be right?
No.
No, because my ones place is a 2, and I know every single time I multiply by 10, that ones place has to be 0. Ones place has to be 0. What else did you notice? Kaylee, what else did you notice?
That 10s are even.
All my products are even. 10, 20, 30, all of those products are even. If you don't have what I have, it needs to be added to your notes. Gina, what did you notice?
I know something of how the 10s and 5s are even.
Ooh, good. How are those related?
Because they both have 10, like when you put 5 to 10, and then 25 to 30, and then you still have 10. They both have 10s.
They both have 10s. You're on the right track. Ryan, what did you notice?
2, 5, 4, 4.
Ooh. What do we call that if we have to do it twice? What do we call that if we have to do it twice? Sabrina? Nope, not commutative property. That's saying we can go in any order, and the answer will still be the same. Gabriella?
What was the question again?
Colin?
Double doubles.
It's not double doubles. It's
Double.
just
Doubles.
doubles.
Doubles. Thank you.
Your 10s are double of your 5s. If you double your 5s, you will get your 10s. Your 10s are doubles of your 5s. Let me prove that to you. Let's pretend I want to know 10 times 4. And for some reason, I've forgotten how to skip count. But I know 5 times 4, 5, 10, 15, 20. 5 times 4 is 20. If my 10s are doubles, double 20 to figure out my 10. What is 20 double? Jackson, what's 20 doubled? 40. 40. Now I know 10s and 5s, excuse me, are easy to skip count by, but if you forget or you don't know, your 5s doubled give you your 10s. Isn't that cool? Maddie, you have something else that you noticed? Yeah, Gabriella knows that too. It's not counting by ones. You're counting by 10s because that number that's changing, that digit, is in which place, Maddie?
10s.
Because I saw a couple of you write, it's like if you keep the 0, it's counting by ones. No, it's not. If it was counting by ones, it would say 10, 11, 12, 13. It's counting by 10s because that digit, when I'm going down, yes, technically that's increasing by 1 digit, but we know that that doesn't mean just 1. That doesn't mean just 2. That doesn't mean just 3. That's increasing by 10. Does that make sense? So please don't put it's increasing by ones if you leave the 0, because that's mathematically not correct. Piper, what did you notice?
I noticed that if you skip count by 5s, then you in the skip counting process, there's always the 10s.
Yes, and it's every second one. You know how I know? Because 5s are doubles. Ready? 5, 10, 15, 20, 25, 25, 30. Every second number is a 10. Turn back to your 2s and 4s hundred chart. Look at that 2s and 4s hundredths chart. I bet you every second 2 is a 4.
It is.
It is?
Every second 2 is a 4. So you'll have 2, and then your 4 will be colored blue. 6, and then your 4 will be colored, or your 8 will be colored blue. That's because your 2s doubled are your 4s. Isn't that cool? I dig it. I'm a fan. All right, turn back to the page that we were working on. No, it's not. Yeah, go. All right, on the page next to that, because you probably filled it up, go ahead and glue in your hundredths chart. It probably will not fit on the same page that you put all your notes in.
Ooh, it does.
Yeah, it will not fit on the same page that you put all your notes in, so it probably will need to go on the next page. Go ahead and glue in your hundredths chart, and then we need to start filling in our mini multiplication chart. So we're going to fill in our multiplication chart, but just to repeat what Aiden just said, he said, hey, if I'm looking either down or across in a specific column or row, I notice that it's skip counting by that number. So for instance, if I'm looking at my 3s right here, 0, 3, 6, that's counting by 3s. If I look at my 2s, even my 2s over here, 0, 2, 4, 6, it's counting by whatever is denoted in the column or row. Alright, we're going to do our 5s first, and we're going to do our 5s going up and down, vertically. 5 times 0. What is 5 times 0? 0. We've got that filled in. 5 times 1. What is 5 times 1? 5. We've got that filled in. 5 times 2. Hey, we've got that filled in.
10.
What is 5 times 3? 5 times 3, Lindley? 15. What about 5 times 4? Elliot? 20. Jackson, what about 5 times 5?
35.
Nope. 25. Gabriella, 5 times 6? 30. Please make sure you're putting this in the right column. You need to be working in the 5s column. Kaylee, what's 5 times 7? 35. What about 5 times 8, Naviana? 40. Ava, 5 times 9? 45. Kaylee, 5 times 10? Not Kaylee. Sorry, not Kaylee. I was not thinking the right person. Madeline, 5 times 10. I said the wrong person's name. 50. Very good. Can I fill out anything else? Yes!
Oh, no.
That squeaking and that beating is not very good for protective. Can I fill out anything else? Emily?
On the very bottom row, you can put in first box 30.
I'm not doing my 10s, though. I'm doing my 5s. Can I fill out anything else? Colin?
You can fill out the 5s on the side
Why?
because they're just going sideways from what we did in the top.
So? Colin, if I turn you sideways, are you still Colin?
Yeah.
It's not the same thing. 5 times 3 looks different. They're the same product. What's that math? Term. We know. Sabrina, I know you know it. Commutative property. The order of my factors doesn't change my answer. It's not the exact same thing. 5 times 3 looks a little bit different than 3 times 5. Those look different, but they are worth the same. So I can go across just like I can go up and down. Okay, what's 3 times 5? What's 3 times 5?
15.
Do you have to count by 3s? No. Can you count by 5 still?
Yeah.
Yes, whichever makes your brain happy. What is 3 times 5? Ryan? 15. Oops, let's put it in the right box. 4 times 5. Could you count by 4s? Sure. It's probably easier to count by 5s though. 4 times 5, Piper? Nope. 4 times 5 will never be 18 because I know my 5s have to end in a 0 or a 5. Piper?
21.
Has to end in a 0 or a 5. So I know 4 times 5 can never be 21 or 18. Emily? 20.
Yes.
5 times 5. That's not a trick question because it's already written in your notebook. Caleb? 25. 6 times 5. Lindley?
6 times 5. 30.
30. Santiago, 7 times 5.
35.
Elliot, 8 times 5. 40. Kaylee, and I do mean Kaylee. Naviana, 5 times, what is it, or 10 times 5, sorry.
50.
Look at all those products you know.
I have one.
Hang on, Santiago. Sabrina, what?
That after the 0, it's going to be a 5.
Ends. You guys did a great job going vertically. Is there anything else I can fill out, Caleb? The bottom 10? Why can I also fill out the bottom 10? Because of the commutative property. What does the commutative property say? Fantastic. I would love the same product. Let's put the same thing, but awesome. All the bonus points go to you, Caleb. You're the winner. Winner, winner, chicken dinner. Just for you. Yeah, commutative property. It doesn't matter the figures you give me. The order of my factors. 10 times 2, or 2 times 10, is still going to give me the same product. So let's go ahead and do this quickly. Just yell it out to me. 10 times 0.
0.
10 times 1.
10.
10 times 2.
20.
10 times 3.
30. 40.
Ah.
30.
10 times 4.
40.
10 times 5.
50.
10 times 6.
60.
Gabriella, get in control of yourself.
Sorry.
10 times 7.
70.
10 times 8.
80.
10 times 9.
90.
10 times 10.
100.
Once you've gotten your mini multiplication chart filled out, you may clear your desk of all math things.